What's up, everybody? My name is Dominick Thornton, and my project was synthesis and antibacterial activity of ibuprofen acyl ureas. Before I begin, here are the amines and amides that I use in all of my products. For each one of my experiments, I began by mixing dichloroethane, ibuprofen, and thionyl chloride inside of a round bottom flask. After this, I used a water-cooled condenser to reflux the mixture for about 30 minutes. Then I cooled the mixture in an ice bath for about 5 minutes before adding potassium carbonate and mixing the mixture for another 15 minutes. Following this, I added TDA and potassium cyanate and refluxed the mixture for another 30 minutes before cooling it in an ice bath for another 5 minutes. Then I added the amine to the mixture and refluxed for another 30 minutes. Next, I poured the mixture into a beaker containing ice and saturated sodium chloride. After this, I extracted the mixture 3 times using ethyl acetate before drying the organic layers with anhydrous sodium sulfate and filtering the rest into a round bottom flask. Finally, I used the Rotovap to remove the solvent and isolate the product so that I could weigh it and calculate the percent yield. Once I had all my products synthesized, I would go down to the NMR room to get an NMR of my product. The NMRs confirmed that the products that I synthesized were successful and meant that I could move on to biotesting. For the biology testing, I diluted each one of my products in DMSO and then put that on an antibiotic disc, which then went on a nutrient agar plate that contained Staphylococcus epididymis bacteria. Here you can see all the tests that I did on my products. As you can see, most of my products had decent sized zones of inhibition, which show that they were effective as antibacterial drugs, but there's still room for improvement. The end.